Alright, the next section in Chapter 7 is dealing with Section 7.4, parallel lines and proportional parts. So again, we are still dealing with the concept of proportional sides with these figures. Now we're just going to include parallel lines into the discussion. So your triangle proportionality theorem states, if a line is parallel to one side of a triangle and intersects the other two sides, then divide segments into proportional lengths. So, AB and BC are the two sides split. They must be proportional to AE and ED. That's the proportion you set up, and you just cross multiply and solve using that kind of information. So here you go. We have our figure. We have our BE and CD, both are parallel lines. We're told that AB is 8, AE is 4, ED is 6, and we want to solve for AC. AC is the entire length, so we'll call this piece X. And once I have X, I just need to add it to 8 to get my final answer. So it'd be 8 over X equals 4 over 6. Again, I should always reduce my fractions as far as possible, so 4 6 is the same thing as 2/3. So I cross multiply. 8 times 3 is 24. X times 2 is 2x. I divide both sides by 2, and I get 12 equals x. Obviously, do not assume this figure is drawn to scale. Clearly, x looks a lot smaller than 8, but x is actually 12. So if x is 12, AC equals 8 plus 12, which is 20. So again, we're using the concepts of proportionality to set up these correct proportions, to then solve for missing segments. So if I want to solve for the entire side length, just call the one piece that's missing in there the X or Y, whatever you want, find it, and then add them together. So for this one, AC, the whole line is 5. So AC is 5. ED is 6. And AE is 9. And we want to solve for AB. Well, to make our lives easier, if I just called AB X, once I solve for X, that's my answer. Now, in order to set up our proportion, I also need BC. Well, I don't know AB or BC. But if the whole line is 5 and a piece of it is X, well, the other piece has to be the 5 minus that X. So for example, if X was 4, this would have to be 1. How do we get that? 5 minus 4. Hence, 5 minus X. So we have X over 5 minus X equals 9 over 6. Again, I should always reduce. This becomes 3/2. So I cross multiply. X times 2 is 2x. 3 times 5 is 15. 3 times negative x is negative 3x. To solve for x, we have to move the 3x over to the other side. So 5x equals 15. We divide by 5, x equals 3. And therefore, since x is AB, AB equals 3. So it's a very straightforward concept. The key is you're going to be given information, enough information to solve every single one of these without much difficulty. Worst case scenario, you're given the entire side length, you just split into one piece x, the other piece the side length minus x. The other one I have to give you everything you need. I want you to go ahead and set this one up on your own. AB is 12, BC is 5, ED is 10, solve for AE. Okay, so fill in the pieces of the diagram, set proportions, and solve. So go ahead and pause. I'll pause the video, you pause as well. And once you have your answer, we'll take a look. Okay, so for this one, it's very straightforward. AE equals 24. AB, BC, ED is known, AE is unknown, that's our x. So 12 over 5 equals x over 10. We cross multiply, we get 120 equals 5x. Divide by the 5, x is 24. And again, we picked x purposely as AE, therefore AE is also 24. So yeah, last one, go ahead and solve this one on your own. So again, set the same information and see what you can do. So for this last one, they give us this BC value is 3 and the whole line AC is 9. And they don't give us the 6 value for AB. But however, if I know the entire line is 9 and a piece of it is 3, well, the other piece you just do 9 minus 3 and you get 6. So AEs are 4, ED is the unknown, that's why it's x. So simple proportion, 6 over 3 equals 4 over x. We reduce 6 over 3 to 2 over 1. Cross multiply, 2x equals 4. Divide, we get x equals 2. Since we picked x purposely, ED also equals 2. So those really are the different ways you're going to see the triangle proportionality theorem play out. I have to give you essentially one of the entire, for the most part, I have to pretty much give you the entire side for one of the triangles. Don't necessarily have to. It just, generally if I don't, then I need to have some way to relate like AB to ED. They both have to be like X in some way. Stuff like that. But for the most part, you'll be given information like this to work out. Letters can obviously change, the diagram itself can change, but this concept doesn't change. Last thing from this section is the triangle mid-segment theorem. So we already know that if I draw a line parallel to one of the sides of a triangle, it splits the triangle into proportional sides. Well, what happens if the line I draw parallel happens to connect the two midpoints of those two sides? Well, obviously if they're midpoints, the split sides are now equal. This is one of the very, very few cases where sides are actually equal in this chapter. But what else happens? Well, it also turns out this value jk is half the entire length of fg. It's one of those nice little things that it turns out to happen. Now, the one area where I'm going to use this information is, again, practicing our systems of equations. So we have our mid-segment theorem. We have our line that connects the two midpoints of the triangles. Two sides are parallel. And I want to solve for x and y. Well, if we notice, x and y are together in a single statement. That's how we know it's a system of equation. So we know 3x plus 4y must equal 7. Why do they equal? Because it's a midpoint. Therefore, the sides are equal. The other one, 9x minus 3y must equal 6. Now, to solve this one, I notice that the x's are very similar. If I multiply the top equation by a 3, we get 9x plus 12y equals 21. Bottom equation is still 9x minus 3y equals 6. Well, if I subtract our two equations, I can get rid of the x's. 9x minus 9x is 0, cancels. 12 minus a negative 3 becomes 15. Remember, minus negative is positive. 21 minus 6 is 15. Divide both sides by 15. Y equals 1. And then once we have y, don't forget to plug it back in to solve for x. So 3x plus 4 times 1 equals 7. So 3x plus 4 equals 7. We subtract 4. 3x equals 3. Divide by 3. X equals 1. So again, for our purposes, our class, you're going to get whole numbers every single time you solve for a system of equations. If you're not getting whole numbers, that's how you know you did something wrong. Okay, we only have one more section left in this chapter. So once we finish that, we will be done, and then it will be time to start preparing for the Chapter 7 test. So I will see you next time.